Hi, Science Project students. This video is to talk to you about how you might make a summary data table for your results section. In a previous video, we learned how to calculate averages or means and standard deviations using Excel from our raw data. This is a project that I'm showing you as an example where you were measuring the height of bean plants after 2 weeks with different types of fertilizer. So we had no fertilizer, coffee grounds, and Miracle-Gro. Here are 10 trials, but we don't want to have our raw data in our results section. It's just too much. It's not helpful. It's much easier to look at the averages and the standard deviations, which show variability. So your summary data table should have the information that I'm going to show you here. You may have some different way of formatting it, although I think the way I'm showing you is a pretty solid way to do it. So here is the document. So we're going to do a summary data table, and this is the general format. You're going to number your data tables. You're going to give them a title, something that has to do with the IV and the DV. You're going to list your levels of the independent variable. You're going to report the means, which is the measure of central tendency. You're going to measure the standard deviation to say how variable your data was. And you're also going to list the number of trials so that we are aware of whether this is a huge experiment with like 1,000 plants or if this is a much smaller experiment with 10 plants. So looking at this, I've started to fill in the title, the effect of different fertilizer on height of bean plants after 2 weeks. We have our standard deviation and number of trials column. This is going to be our IV, which will be type of fertilizer. Oops, sorry, let me spell fertilizer right. Of fertilizer. Okay. And I might not even put IV in there. I'll just say type of fertilizer. We're going to have our mean, and you can be more specific, mean height. And make sure you put your unit in there, which was centimeter. Now, the type of fertilizers we used was no fertilizer, coffee grounds, and Miracle-Gro. Our mean heights, if we go back here and look at it was 18, 15.2, and 6. So we'll go back to this. Was 18. And again, you want to put out to the measurement that you had. This was a ruler that went out to the tenths place. You want to give yourself credit for that. You should always, even though it's a 0.0, you should always go out to that decimal place. We've talked about significant figures in chemistry, maybe not in bio, but you want to give your measuring device credit to the fact that it went out to the tenths place. Standard deviation should round to the same place as the measurement itself. So this one was 1.8. And this one was 2.3. And the last one was 1.6. So there's quite a bit of variability. So the smaller the standard deviation is relative to the mean, the more precise, the less variable your data is. So the Miracle-Gro, there was quite a bit of variability compared to the mean, whereas the no fertilizer was a little tighter, the data, compared to the mean. You also want to put in your number of trials. And this gives me a much easier picture than this, okay, of not having to look at all these numbers. If I look at this data table, I can now see how much better actually the fertilizer probably was not very useful. It certainly didn't exceed the mean of the no fertilizer. And I can see the variability of the data, and I can see your number of trials. So this gives your reader a very clear, very concise picture, and that's what we want to do as scientists, to make it concise and easy to understand. So you should be doing a summary data table in your results section. Your raw data should be available to your teacher, but should not be included in your results section.